Hello, today let's have a look at how to get a 3D spatial voice chat running in your Unreal Engine project using ODIN by 4players. If you followed the last episode from our video tutorial series, you have a non-spatial voice chat running already. And so in this video we will extend it. We will add a proper attenuation to the streams coming from other clients, which means that they will be adjusted in volume and frequency depending on where they are located in the level. The main challenge for this setup will be to associate each stream with its according actor in our Unreal level. To achieve this, we need to prepare some things which we will go through in this video. Since it is the most used network solution, we will have a look at how to implement this using the Unreal networking tools. Thus, you need a fairly good understanding of the replication system in the Unreal Engine in order to fully understand this guide. If not, I have prepared some links for you in the description to follow. To complete this tutorial, it might not be necessary, but it will be helpful in understanding everything for sure. Also, you can use any networking framework you like, because ODIN is working independently. You will just have to connect the dots a little bit differently when you are using a different framework, for instance Photon Realtime. For this video, you can either continue to work on the results that you got from the last video, or you can access a sample solution in this tutorial's project repository linked below. Just go to the repository link and switch the branch to the result of the video you are continuing from. So for now it is result video 1. Once switched, you can download or check out that state of the project as usual. If you have the repository checked out, you can also use your Git client, for example GitHub Desktop, to switch the branch easily. Our first step will be to propagate a unique ID for each client that is consistent across all instances of our game. You can do that with the help of the Unreal's Replication. To begin, open the BP ODIN character blueprint and create a new instance variable here. We will change its type to GUID and name it ID. You can use any other type as long as you make sure that each client can have its own unique value for it. A GUID, or globally unique ID, is, as its name suggests, unique on a global scale. So the purpose of the GUID does not matter, and we can always assume that a properly generated GUID is also unique in our application. Now we will just need to generate a proper value for that GUID once and assign it to this variable. By the replication rules, we cannot replicate a variable from one client to another, only from the owning client of an actor to the server, or from a server to all clients. So we will generate the value for this variable on the server and then pass it to the other clients. In the begin play event, first check if we are on the game's server instance, and if so, generate a new GUID and assign it to the ID variable. Now to send this value to the clients, we will change the replication property to rep notify. This adds a new function to our blueprint that is executed locally once the variable has been replicated. In here we want to add a mapping from the send GUID to this local character instance. There are several places to do this, but we will use the game instance for this, because there's only one game instance on each client of the app. Although you should keep in mind that the game instance is persistent across levels, which might be helpful, but also forces you to tidy up this map, for example, when the client joins a new Unreal level with different characters. So now we will create a new class, give it a name, for example BP ODIN Game Instance, and derive it from the Game Instance class. Then open it and create a new instance variable here. Change its type to GUID as well, but make a map out of it and set the value type to the BP ODIN character class. Back in the onRepID function of our character, we can now add the character to the game instance's map using the just replicated GUID. So we will place a cast to ODIN game instance node here, and then get the ID to player character map. Drag from it to place an add node and bind this character's ID to it, and a reference to itself. Lastly, we also need to change the default game instance class to our newly created one. Open the project settings, go to Maps and Modes, and change it at the bottom of these options. The next thing we want to do is add the ID as user ID to our join room call of ODIN. We will add it to our access token creation procedure. Since we want to make sure that the player ID has already been replicated to the local client before we join the room, we can now move the call to our init ODIN event to the onRepID function of the ODIN character. Just check if it is the owning client before calling it. On this occasion, we can also pass it the character's GUID so it can use it to create the access token. Now back in the init ODIN event, go to the generate room token function and bind its user ID input to the incoming GUID after casting it to a string value. This now encapsulates the GUID in the user ID property of the access token. Again, it is worth mentioning that normally you would not want to do this on the client, but rather on the game server, so that users cannot simply act on behalf of any other user by creating an access token with a different user ID. And also because you do not want to add your personal ODIN access key to the client executable of your game. For the sake of this tutorial, we will leave it now as it is. Finally, we can use the ID sent in the join room call in the onPeerJoined event. Bind a new custom event to onPeerJoined of our ODIN room in the ODIN client component and name it onPeerJoined event. Here we can get the user ID. We can create a peer ID to player ID map as an instance variable by creating a map with integer keys and GUID values. We can then add a new key value pair here so we can later get the correct GUID again. Also, make sure to add the own GUID and peer ID to the map when we have successfully joined the ODIN room ourselves. Now that we have that mapping as well, we can finally find the correct player character in the onMediaEdit event. Here we can first find the correct GUID using the incoming peer ID. And second, find the correct ODIN character actor. Now we can either add an ODIN synth component to it dynamically like we did before, or we can add it to the blueprint in the blueprint components pane of the ODIN character. Adding it dynamically is similar to the method we used with a non-spatial voice chat, But adding it to the player character's components has the advantage that we can adjust its properties, for example the attenuation, more easily. Lastly, no matter which method you chose to use, assign the incoming media stream to the ODIN synth component, and we are done with the logic part. Now you can adjust the synth component's properties and its attenuation to the needs of your project. Now let's hit play again and talk. We can hear the differences in the audio stream, depending on where in the level the characters are standing. So now you have a fully functional spatial voice chat already. We could start to add more features like team internal chat or radio chat functionality and push to talk. Also, we could add options to enhance voice chat quality for each client individually. ODIN's APM settings that change the behavior of the audio streams. This way you can, for example, add a noise suppression or volume gate functionality easily. We will cover these in the next video. If you want to reach out to us, feel free to join our Discord server or follow us on social media. The links are in the description. So for now, have a nice rest of your day and see you then. Bye!